prove that we have tested enough and we can release the product. Otherwise, we will test the product for hundreds and hundred years and we won't be able to release. So there are three categories of test design techniques. Yes?
Yes.
Three categories of test design techniques. One, black box. It is also known as behavior based. It is also known as functional. Yes. Second one is white box. It is also known as structural, or you can call it structure based. Yes. And third one, we discuss briefly, experience based. Yes. So what is black box? As we discussed previously, we do not have knowledge of the internal structure of the application and we design the test cases. So from where do we design the test cases? The test cases are based on test bases, yes, such as requirements, specifications, etc. Yes. Test basis can be anything from where you derive your test cases. It can be legacy system. It can be any piece of document you are using. Yes.
Yeah.
User stories. Yes. User stories, use cases, etc. Yes.
Yeah.
What is white box testing? We have the knowledge of the system, have the knowledge of the internal structure of the system. Yes. And so our test cases are based on the information how the software is constructed. Yes. Test cases based on information on how the software is constructed, means based on the code. Yes. Experience based. Here we say that we have the experience of working on similar technology, similar software. Yes.
Yeah.
So here our test case is based on, can you say test case is based on the knowledge of testers, yes, users, etc. And these users have worked on, so here's the knowledge of the testers and users. So these people, they have worked on similar technology previously, so they have the knowledge of software and its usage. Yes. As they have experience of working on similar software, similar technology, they know where they can find the defects. Yes. And where they can find the most. So knowledge of likely defects and their contribution, distribution. Yes, where you can find them most. Any questions so far?
Last point, I cannot understand likely defect and the distribution.
So you have worked on the similar technology and similar software. So if you have worked previously, you know where you will find the defects, in what area you will find the defects, and where you will find most defects.
Okay.
As for example, if you work, then you will say at boundary there are defects there, more defects there. Why? Because there are n number of different data types. The developers might have forgotten it. Yes.
Yeah.
They might not have implemented the correct rules.
Okay.
So where you can find the defects, if you are testing the defects any software, then you will say in this area you will find the most defect and you will concentrate testing that particular piece of area. Yes.
Yeah.
Any other question?
No. Thank you.
The next one is black box techniques. We will discuss in detail here.
Okay.
So in black box there are four types of techniques. Yes, four different techniques in black box. One, equivalence partitioning. So what happens in here? If you want to understand this, then you can say equally distributing. So as for example, there is an factor is there in maths. Yes, you have 5 children and you have 25 chocolates, distribute equally. Yes, so this is like equivalence partitioning. But here we have the rules. Based on those rules, we will partition the requirements, apply some partitions, and accordingly we will use some of the values.
Okay.
Next one is boundary value analysis. So each and every range will have some boundaries. Yes.
Yeah.
So when we test, or our test cases are based on these boundaries, we call it boundary value analysis. This is important because most time we find more defects at the boundaries. Okay.
Great.
When we apply boundary value analysis technique and design the test cases, we will find defects in that area.
Okay.
Third one is state transition testing. Yes. So whatever we are doing, we might have used some of the state. Yes. When we use this kind of state, so it moves, that particular state might move from one state to another state. And whatever transitions is done between these two states is called state transition testing. So I give you a fan is there. What state it could be? It could be on and off. Yes. So on is a state and off is a state. From on, if it moves to off, that is a transition. Yes.
Yeah.
There's a speed there, 1, 2, 3. So 1 is a state, 2 is a state, 3 is a state. Yes.
Yeah.
So when it moves from state 1 to 2, there is a transition, and that covers in state transition state test. There is another, it is a standby, you call it. Yes, it doesn't move and you can rotate it, called swing mode. Yeah. So it does not move, so that is one state. Please change to swing mode, that is a state, and whatever transition is done between these states, we test it. Yes. State transition testing. Decision, this is most important. No, this is one of the important decision table testing. Yeah. So based on the business rules, you prepare a table based on the decisions you are making and design the test cases that becomes decision table testing. This decision table testing is widely used when you use any of the store cards. And nowadays, you see that if you apply the stored scar for literally everything, you might have at least 100 store cars. Yes, each and every, I remember long time back only Boots was giving. Nowadays each and every petrol station, each and every stores, they started giving their cards. Yes.
Yeah.
So you go there, you spend certain amount of money. Based on the certain amount of money you spend, you get some points. Based on the points, you can spend something. Yes.
Yeah.
And these techniques are used. These techniques are used to design dynamic test cases. Yes. So let's discuss this one in detail. Also, there is another one called use case testing. Yes. So you have the use cases. Do you remember use case? Case testing. So you have the transactions between actor and the system. Based on the flow, you design the test cases. That becomes use case testing. Let's move to the first one, equivalence partitioning. So what is equivalence partitioning? Here the input and output values are divided into different groups based on the application's behavior. Yes. So you can say input and output values, okay, are divided into groups based on the behavior of the application. Yes, this behavior is based on the business rules, but instead of putting that, I will put any value, okay, any value exhibiting the same behavior are put or are classed okay, are considered the same group. Yes, are placed in the same group. Yes. So as for example, any value you have from one range to another range, those particular values have exactly the same behavior, and when you have the same behavior, you put them into the same category. Yes, or you can put them into the same class or same groups. These groups, okay, so you say groups can be referred as classes or equivalence partitioning. Equivalence partition. Yes. When now understand, see what happens when you are in a range, within a range, if you use any value within a range, will become valid equivalence partition value. Yes, If you use outside this, yes, valid equivalence partition, but you can say outside this range, then it becomes invalid value. So why you go outside and inside? When it is inside, this particular application will have exactly the same behavior. Yes.
Okay.
When you go outside, as soon as you go outside, the behavior changes. Yes, and that's why your changes. Yes, inside values or within values. Yes, within range value have same behavior. As soon as you go outside, the behavior changes. Let me give you an example, then it will make more sense to you and you will understand. So the example I'm going to give you is marks. Yes, whenever you have any exam, you have 100 marks. It can be more than, but we mostly standard is 100 marks paper. Yes. So you have the 100 marks. So how many marks can you get out of 100? Highest you can have 100. Yes.
Yeah.
And lowest you can have
0.
What happened? The lowest you can have is 0. Yes. So you say 0 and highest is 100. Yes. So when you have any exam paper, you have 100 marks, you can either get 0 or 100. So when can you get outside 100?
No.
Outside 0, no. So if you take any value outside 0 and outside 100, yes. So this is just you understand outside, yes. Outside the range, what will become? This becomes invalid value or invalid partition. Yes, invalid partitions, because you can't have any range outside 0.
Yeah.
Any value you take inside from 0 to 100 becomes a valid value. Yes.
Yeah.
So here to here you have a valid value. Yes, this range is there, 100 valid value. Yes, but even 0 to 100 you can have even different partitions within them. Yes.
Yes.
How different partitions within them? So it won't be exact, but let me put here something. Okay.
50.
So I put 40. Yes. 50, 60 and 70.
Yeah.
Yes. This is 40. This is 50. This is 60. And this is 70. So if you get from 0 to 40 marks, what happens? You fail the test. Yes.
Yes.
Fail. Then if you get any marks from 41 to 50, what will happen? Yes.
Yes.
What will happen? You say pass. Yes. If you get 51 to 60, what happen?
Pass.
Second class. Yes. If you get 61 to 70, first class. Yes. If you get over 70, what happen? distinction. Yes.
Yeah.
So based on the number of percentage you are getting, this is category. This is the valid rules we have. If you get less than 40, 0 marks to 40, you fail the test. If you get 41 to 50, you get pass class. If you got 51 to 60, you get second class. If you get 61 to 70, yes. So 40 is the range. You get 40, then yeah, this is the range. So 40 the range we have given. 50, this is the boundary. Whatever we are giving is the boundary value. Yes. 40, 50, 60, 70, 100 and 0. Yes. If you use any marks from 0 to 40, the behavior is exactly the same. Yes. If you use any value from 40 to means 41, I will say yes. Or if you say I did 40, so 40 to 50, behavior is the same. Yes. 50 to 60, behavior is same. 60 to 70, behavior is same. 70 to 100, the behavior is same. Yes. Based on that, we will decide the exact value. So if you take 25 marks, what will happen? Fail. 45?
Pass.
Yeah, so this proves any value from these categories or any value from this group are classed as same category value or having the same behavior. Yes. And this proves if you take any value, that proves. And this, if when your test cases are designed based on this, it becomes equivalence partitioning. So you don't need to test 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 40. You don't need to test 41, 42, 3, 4, 5, 6 up to 50. Yes. You don't need to test 71, 2, 3, 4, 5 up to 100. Yes. In 71, 72, 73. Because the behavior is same, you can use any of the value. Yes. If you use any of the value, you can verify the results. You can verify your condition. And when your test cases are designed based on this, this becomes equivalence partitioning. Yes, any question?
So it is same theory apply in this equivalent partition.
This is equivalence partitioning only we have discussed.
Yeah, I know.
Yeah.
See, it is the equivalent.
Yeah, go on equivalence partitioning. Yeah.
So is it require the participant equally in this one?
Yes. This equivalence partitioning is valid throughout the business. Any business you use.
Okay.
As for example, I use a store card which is Boots or the Nectar card. Yes. I don't have the rules and regulation. I don't know. But if you spend certain amount of money, you get some points. Yes. And some point is a specific number of points. Yes. So based on this, you can categorize these rules and regulations. Yes, different classes, and accordingly you can test. As for example, if you spend £1, you get 1 points or 5 points. I don't know how much is this all rules for here. Then you say that spend £20, £25, £30, £40. Yes. You say that if you spend less than £10, you will not have any points. As for example, I give you very good example is delivery system. Yes. In delivery system, say that if you spend less than £20, yes, what happens? You need to pay for the delivery. Yes. pay for delivery. If you spend over 20, so you can say from 21 to 50. Delivery cost £1. If you spend over 51, we have to go by the boundary, 50. Then you have to ask, is this including or excluding? Over 51 or over 50? Yes, from 51, delivery is free. So there are three partitions here. Yes. So you need to spend £10, £15, and say that the system says the delivery charge has been stated. If somebody spends 21, so 20 is the boundary at 21, then to 50, you say that £1 is added to the delivery. If somebody spends more than 51, you say the delivery cost is not included and it is free. Yes? Any question?
No.
Let's move to the next one. The next one is boundary value analysis. Yes? Yes, boundary value analysis. So as we have discussed in here in this one, in this class, we have boundary 0 and 100. Yes?
Yes.
If you 0, 100 is a valid boundary. Yes?
Yeah.
For this example, 0 to 100, 0 and 100. Let me put 0 and 100. Valid. Outside 0 and outside 100, invalid boundary. Yes, agree? So if you take any value outside, this becomes invalid and that value would be rejected.
Yeah.
Yes, invalid value should be rejected. Invalid value rejected. Valid value accepted. Yes.
Yeah.
Here you can have 2 or 3 boundary markers. Okay, it is advisable to use 3 boundary markers. Yes. So let's go to our same example. Here we have a different classes, 0 to 40. 40 is a boundary. Yes.
Yeah.
50 is a boundary. 60 is a boundary. 70 is a boundary. 0 and 100 we have discussed already. Yes.
Yeah.
So let's go and discuss for 0. How many boundaries? If we are using 3 boundary markers, then what you do? One value on the boundary. Okay. One value outside boundary. Outside the boundary. And one value inside the boundary. Yes. So we have here 0. So what would be? 0 is a boundary. Yes.
Yeah.
0. Yes. On the boundary. Yes. Then what happens? Outside -1. Yes. any one, you take one which is inside the boundary. Yes, so let's discuss here only. -1, if you use that value, what will happen?
It's rejected.
It will be rejected.
Yeah.
If you use 0, what will happen?
Yes. Valid.
Accepted. Is a valid boundary, and based on the behavior you will get the result. Yes.
Yeah.
1, it is inside, so it will have exactly the same behavior. Yes. You have another class which is 40 boundaries. So can you give me what would be the boundaries for 40 range?
0 to 40.
No, we have we have discussed 0. Yes, this is the 0. The next boundary is 40. Yes.
Yes.
So for 40, what 3 values you are going to use?
Means on 0 to 40s.
No, 0. 0 is a different thing. 0 to 40 is a class. It's an equivalence partitioning class. You can say 0 to 40 is a class. Here we are not talking about the class. Forget it. They both come together. Equivalence partitioning and boundary value analysis come together, but here we are talking about only boundary, and your boundary is 40.
Okay.
Then what 3 values you are going to use to verify this boundary for 40?
40. 1.
Yeah. Yes, 40. Then go on. 40 on the boundary. Yes. You say 41. What is 41?
It is outside the boundary.
Yes, from 0 to 40, 41 will become outside the boundary. Correct. What other value?
41. 0. 0 is on the boundary.
Yeah,
40.
0 to 40. 0 is a boundary for class and 40 is a boundary. So 0 to 40 is a class. So what other boundary you are going to use?
Like 39 inside.
Yeah, 39 inside
the
boundary. Yes. Let's go to another class. Class 2 or equivalent. I will say class 2. Class 2 is 40 to 50. Yes.
Okay.
So 40, 50. Okay, so what you will say? 40 is on the boundary.
Yes. 41 is inside the boundary.
41 inside the boundary.
Outside the boundary.
39 outside boundary. What will happen to 50?
What? 50?
Yeah, 50
is also on the boundary.
Yes, 50 is on the boundary. Yes. What other value you are going to use?
2 to 50 is finished.
How?
Okay. You said 40 to 50.
Yes. Not finished. We are using 3 boundary markers.
Okay. Then 51 is outside the boundary.
51 outside the boundary. And
49 is inside the boundary.
49 inside. Let's discuss this one. There are other things, but I explain you. Okay. So this 0 to 40 including. Let's go to 0 to this is one value. Let me put 1 so it does not misguide ambiguity. Yes.
Yeah.
So when you have a class 0 to 40, yes, class 1 0 0 to 40. So 0 and 40 including. Okay, let me put inclusive. So it does not inclusive. Yes. Then here we have to do it in a different way. So if you get 0 marks or 40 marks, you fail the test. Yes.
Yes.
So you won't have -1, it will be rejected. But as soon as you got 41 marks, what happens?
Pass.
No pass. Behavior changes. Pass is the correct. The behavior changes. Yes.
Yeah.
When it is outside, behavior changes. Yes.
Yes.
So you verify when the behavior changes. Here 40, here we have included. So if you get 40 marks, you will fail the test. Yes. So 40, what happens in here? Fail. Yes. As soon as you get 41, what happens? Behavior changes. What happens at 50?
Behavior change.
No, 50 is the same behavior. For same behavior.
Okay.
What happens at 51?
Behavior changes.
So when we test any application at the boundary, our main intention is to verify the application behaves or the behavior is as expected. Yes.
Okay.
When it has to change the behavior. So in boundary value analysis, you have valid value and invalid value. Value identified by the boundary value analysis becomes a valid partition. Any value identified as outside the bound partition, it becomes invalid value. Yes.
Yeah.
So what is to prove? Here we are proving points is the rule changes. At the boundary, we are going to prove when the rule changes, the behavior is as per expected. We can take 2 boundary markers or 3 boundary markers. Yes.
Yeah.
To prove our points. When you have 2, using 2 boundary markers. When you are using 2 boundary markers, then what you are going to say? 1 value on the boundary and 1 value outside boundary. Why outside boundary, not inside?
Why?
Because at the boundary, the behavior will be exactly the same.
Okay.
When you go outside, the behavior changes.
Yeah.
Yes. So you verify this on the boundary, outside. Yes. But when you have a big list, you will might think for this specific class it is inside. Yes. But for that, if you take -1 and 0, 0 and -1, yes. So -1 is outside. Yes.
Yeah.
And 100 and 101. So 101 is outside. If you have a boundary, here I put inclusive value for it. Can you see? Inclusive for the fail. So I say even if you get 40, you fail the test. You pass the test when you get 41. Yes.
Yeah.
If it is outside, you say the 29. Then what happens? You take the value outside. Yes.
Yeah.
So if you have the boundary 40 but you fail at 39, as soon as you get 40 marks, you pass. So here we have to make sure when the exactly behavior changes. When we talk about the boundaries, we have to talk about inclusive outside. Yes.
Yeah.
Any question? Any questions so far?
No.
Okay, let's move to the state transition testing. This state transition test design technique is a black box test design technique, yes?
Yeah.
In which test cases are designed to execute valid and invalid state transitions. Test cases are designed to execute valid and invalid state transitions. Yes. Here you will say what is valid and invalid. Yes.
Yeah.
So we can create a diagram. This creates a diagram showing the state a component may be. Yes. Here what we will create a diagram showing the states of the component. Creates a diagram. What it will show? Show the current state. Yes. Or status you can say. And from transitions from one state to another one. Yes. Transition from one state to another. And this happens by events. So events that cause those transitions. And the events causing these transitions. Yes. So let's discuss this one in detail. You are in state 1. So let me go and show you one diagram. So it makes more sense. So let's talk about one state is there. Yes. And there is another state there. Yes. Forget about it is not properly designed. So you have state 1. Yes. And from that state it goes to state 2. So when it goes from state 1 to state 2, there is an action there. Yes. Some action there. Yes. I cannot do a straight line even. That's fine. And the state from here to here, whatever it goes, that is known as transition. Yes. And this transition does not happen automatically. Some events there which causes this transition. Yes.
Yeah.
So in state transition we will discuss this. And this technique is widely used. State transition technique is widely used in embedded software industry, where technical automation in general. Yes.
Okay.
This technique is also suitable for other business objects as well, like specific states or testing screen dialogues flows. For example, internet applications or business scenarios. But it is widely used in embedded software system. If I have to give you a very good example, I have given you the fan example, but I give you another example of a switch. So how many states can a switch have? Can you tell me? The light switch I am talking about.
1.
How 1?
Is on and off.
So how many?
Switch is only one.
Switch is only one, but how many states can be in switch, that particular switch?
Two, off, on and off.
Yes, but you were saying one, yes?
No, I'm saying switch is one.
Switch is one, switch on and switch
Off.
off. So there are two states there, switch on and switch off.
Yes.
Is there any in this switch on and switch off, they are valid states? Yes. Can there be an invalid state for a switch?
No.
Think. Can there be an invalid state for a switch?
No.
I give you 2 minutes to think.
On and off. No.
Just think. Think and say no, it is not the answer.
Okay. Valid.
Yes.
When is going to off is called invalid.
No, off is a valid. I say valid state transition. I say valid state switch on and switch off, they are valid. I'm talking
When
about
working. When
what?
is not working.
Yes, invalid. If the switch is faulty,
Yeah.
then what happens?
Is invalid.
Yes, it is invalid.
Okay, yeah.
Invalid state is switch faulty. See, this is testing. Testing is thinking only, okay? Faulty. This becomes as invalid. Yes?
Yeah.
So I give you an example of a wristwatch. Yes? Have you used a wristwatch?
Yes.
Yes, you have used, I know. In a wristwatch, what type of states you can see? What states?
For watch.
Yes. Just think, then we will discuss. It is thinking, yes?
Yeah. 1 to 12. Is it transition?
No. It's a time, but state.
Only one wristwatch.
No, wristwatch is watch one, the states. Okay, let's go by. It can display the time. Yes? Display time.
Day or night.
Oh, it has day and night as well. But say one display time and display date. It can be so many. Nowadays the watches are okay. Smart. Display time and display day. Yes?
Yes.
Display day. No, display date, not day. Date. Yes, you can change the date. And the time you can see it. What is time? 12 o'clock. Yes. And what is today's date? You can see date and time, right?
Yes.
So when you are in this is display time, okay?
Yes.
Display date. Display date. Yes. And this is display display time. Yes, this is, you can consider state 1, S1, and this one you can consider S2. Yes,
Yes.
from display date, can you do any other action? I'm asking you, can you do any transition from display date?
No.
Today is 26, yes?
Yeah.
But what if your wristwatch displaying 25th?
It's invalid, right?
How invalid? It is invalid, but can you change the date on a
Yes.
wristwatch? Yes,
Yeah.
you can change the date. Yes.
Yes.
What is when you change the date? That's
It's valid.
that state say not invalid. That is state S3. Yes,
Yeah.
and that will be known as change or alter. You can use any one of them only. Date. You can see S3. Yes.
Yes.
Try to understand, then you will understand these transitions. From display time, what you can do? From display time, what can you do? Change or alter time. That will be S4. Agree?
Yes.
So either your watch displays date or time. If you want to see, your clock is displaying time, and if you want to display date, then you press a button. Yes,
Yes.
am I right?
Yeah.
If you are on the date and you change the button, and that button will display the time, that is known as change mode. It will change the mode from date to time, and time will be displayed. If time is displayed, and if you want to see date, then you again change the mode, and when you change the mode, it will display date. Nowadays date and time together displayed on the same screen. Yes,
Yes.
with the smart watches.
Yeah.
But if it is, this is a functionality we are testing, so we can understand. So what here, what you are doing, you are changing the mode from time to date, date to time. Yes, so this change of mode is your transition. Yes, from display date, you want to alter date. What you will do? Your date is being displayed and you want to change the date. What you do? Yes,
So I want to change if it displayed.
yes, you want to change the date, then what you do?
Press the button and change date.
Yes, there can be a reset button. Yes,
Yeah.
so you click on reset button, then what you do? You press reset button, and also you do some other activity. Yes,
Yeah. Change the date.
yes, reset, change the date. Yes, you change. So from display date, you go and click on reset and you change the date physically. And then again, if you want to display the time, what happens? You just click on the display time. You need to first set the date, yes, and then say display date. So here you say set date and display date, and it will display the new time. It will not display the old time. Yes.
Yeah.
Exactly the same we will do with time. Yes. Right.
Yes.
What you will do when you are on time mode, display time, you click on reset and it will allow you to alter the date. You alter the date and then click on set the time, and that set time will set the specific time you have set, and then click on display time and it will display the time you have set. Yes.
Yes.
Right. So what are the transitions you are doing in here? Let's go here from S1 to S3. Yes.
Yeah.
From S3 to S1, you can see the screen. Yes, the boxes where the lines are. From S1 to S2, from S2 to S3. Yes. From S2 to S4 and from S4 to S3. Yes. You can say change mode, display date and time, other things are there. Do you have any transition between S3 to S4?
Yes.
S3 and S4?
Not directly.
No, there is no. So that is considered as invalid transition.
Okay. Yeah.
Yes. So wherever you can go from one state to another state, that becomes a valid, and from one state to another state you cannot go, that becomes an invalid. Yes. And if you state this, that becomes invalid state transition testing.
Okay. Yeah.
Any question?
No.
Fully understood?
Yeah, it's fully understood.
Okay, let's move to the another. Decision table testing.
Table testing. Does it?
The next one we will discuss is decision table testing. Yes.
Yeah.
Decision table testing is a black box design technique. Yes.
Yes.
These decision tables are a good way to capture system requirements. Yes. You can capture the system requirements that contain logical conditions, where we have the logical conditions, and to document internal system design. They may be used to record complex business rules. As I said yesterday, where we are going to use this? To record complex. It can be simple as well. Yes. Complex business rules that a system is to implement. When creating decision tables, the specification or the requirements are analyzed and conditions and actions of the systems are identified. You analyze the requirements and you identify the conditions or actions, and the input conditions and actions are stated in such a way that they must be true or false. Yes. The decision table contains triggering conditions, often combinations of true and false for all input conditions and the resulting actions for each combinations of conditions. Yes, we put these conditions in a table. Yes, each column of the table corresponds to a business rule. We have to have the business rule that defines a unique combinations of conditions which can result in an execution of the actions associated with that rule. Yeah, so let's create a table. Can I put a table? Unfortunately, I don't have Excel. If it opens, that's good. Just wait. If it opens, that it will help us. Yes, I think it will launch. So here what we are going to discuss, we have the rules. Based on the rules, we have the conditions, and based on the conditions, we have the entries, and based on the entries, conditions, we will have some actions. Yes, and we will apply. So until it loads, I give you example. If you work on any mortgage system, mortgage calculator means, yes,
Yeah.
you will have some rules. If you borrow from certain amount to certain amount, the interest rate would be this much. Yes,
Okay.
if you borrow from this one to this one, the interest rate would be this much amount based on the property value. Yes, so let's discuss in here. So here we have a table. There is a table there. Yes, let's class this one as table. This is a whole table is there. In these tables you have the conditions. Yes,
Yeah.
here we are going to state some conditions. So you say I'm just randomly doing it. There's no rules in here. Okay, my Excel. So here you will have conditions. So we call it condition stubs. Conditions. Yes. So condition stubs. Based on the condition stubs, you will have conditions actions. Yes, action stub you can say. And you have rules. Here you have the business rules. Yes, business rules. Rule 1, rule 2, etc. Yes, agree? Based on the rules, you will have some actions. You are going to perform some actions. Yes,
Yeah.
based on the rules, the actions will be that. So action and this. Here you remember based on the requirements. Based on the requirements, we have the conditions.
Yeah.
Yes, based on the conditions, we will have some actions. Agree?
Yes.
And based on the conditions, we will have some rules, and based on the rules, we will have some entries. Yes,
Yeah.
agree?
Yes.
Let's discuss one example, which is traffic light system. If you are driving, even if you don't know driving, you might know some traffic light rules. Yes, how many lights can be there on a traffic light?
3.
3. Red, it turns on and turns off. Yes,
Yeah.
agree?
Yes.
You can have another traffic light.
Yellow. Green.
Green, the green can be on and off. Yes.
Yeah.
And then you can have amber light. Yes.
Yeah.
Or some people call it yellow. I call it yellow as well, but it is amber. Can there be any other light?
No.
No. Based on these lights, what rules you can say? You can have rule.
Government rules? Sorry. Traffic light.
Yeah, based on the traffic lights, what can the rules be?
Stop, go, and
Yes, correct. When it is red, what you do?
stop.
Stop. From red, it is turning to amber and then it will turn to green. Yes. So this is not properly. This is not the correct. Let me put it here. Yes.
Yeah.
Did it this one. So this makes more sense. Looks like. Yes. So you have a red light. From red, it can turn to amber, and from amber, it can turn to green.
Green.
Yes.
Yes.
Red means stop.
Yeah.
From red, it is amber. Then what you do? Ready to go.
Ready.
Yes.
Yeah.
So these are the decisions you are making based on the traffic lights. And from amber, it is turning green. Then
Go.
go. These are what? Valid decisions. Yes. The rules. Can there be any other rules?
For light?
Yes.
No.
Just think.
For lights?
Yes.
Yeah, for left, right.
No, just forget about left, right. There can be some left, right, but they are still lights. Okay. What can be the other rules other than these three we have discussed?
For lights also directed to which direction you have to go, like north, east, west, like.
No. Just forget about direction or anything. Just think of the lights being displayed. You have three lights.
Okay.
Red, amber, and green. Forget about on and off now. But based on these lights, what other rules? We have discussed red light is on and off, amber light on and off, and green light on and off. What can there be another? Think of scenarios.
No.
Okay, I gave you. What if there are two lights displayed at the same time or three lights displayed at the same time?
Is fault.
Yeah, so these conditions we have to check. This is testers thinking. Yes.
Okay.
So based on these lights, you have a rule. Either it is red, amber, or green. But what if all the three lights are displayed?
Is
Yes.
faulty.
So here lights displayed, here lights displayed, here lights displayed. There can be more. Okay. Scenarios. Let me insert. Or what can be that another scenario? Can you say?
All lights are switch off.
Yeah, so all lights off, switch off. So there is one more required. Yes. So there is no lights displayed. Yes. And here you have three lights, all three lights, or either them two displayed or them two displayed. Yes. Based on that, you are going to make some decisions. Let's make the decisions. What can be the decisions? One is slow down. Yes. Prepare to stop. Stop. Prepare to go. Go. Report a fault. Yes.
Yeah.
Based on this, you can have these decision actions. What are these actions? Slow down, prepare to stop, stop,
Good.
prepare to go, go, and report the fault. Yes, there cannot be any other decisions than 6.
Okay.
Let's discuss. Do you want me to write this in this table? Let's write then, yeah. What actions you can have? Slow down, prepare to stop, stop, prepare to go. You will say why this go, and report the fault. Yes.
Yeah.
So let's discuss how we can do it. Okay, the light is red. Then you are stopping it, yes? So you can see in here, when the light is red, you stop. Yes?
Yeah.
So you can say stop. But light is amber. From green light, it is turning amber. Then what you will do?
Go.
The light was green. No, the light was green and it is turning amber. Then what you do?
Stop. Yeah.
Slow down. Yes,
Slow down.
slow down. Yes. From green, when it is turning to amber, you slow down. When it turns red, what you do?
Stop.
Stop. Yes. So these actions you will do. Slow down, prepare to stop when the light is red. Yes, you do these actions. Slow down, prepare to stop, and stop. But when it is turning from green to red, you can see it. Yes, the light was red. From red, it is turning to amber. What you are going to do?
Red turning. Slow down.
No, from red it is turning. Prepare to go. You don't go. Prepare to go, then go. Yes.
Okay.
Agree? When it is amber light displayed, what you do?
Yellow is called. Prepare to go.
No, you don't know, just amber light. You haven't observed.
Amber means green, yellow, right?
Yeah.
So is prepare to go. Prepare
No,
to go.
that is, see, I have given you that actual example. Actual, when it is red light, when the light is red, you slow down and stop. When it is amber light, you slow down and prepare to stop. That is the decision. You don't know whether when you are observing, when you are driving, you can observe what the light weight is going from green to amber or red. Yes, that time this is the practical way I show you. But when it is red light, you slow down, prepare to stop, and stop.
Yeah.
Yes.
Okay.
When it is amber light, yes.
Okay. Yeah.
In that case, from red to amber it is going. I have ticked it from red to amber. So when from red to amber, what you prepare to go, and when it turns green, you go. So green means go. Yeah. You don't know, and this amber light is, then you, when the amber light is there, you don't assume that you are ready to go. You need to slow down and prepare to stop. Yes, that is your decision. But you know, when you know from red it is amber, then you prepare to go. Yeah. When there is no light displayed, then what you do?
Report a fault.
Yes, but you slow down and stop and report the fault. Yes. What if all the 3 lights are displayed?
Report the fault.
Yes, but you have to slow down and
Okay, slow
That
down
means
and
you
stop.
don't know, yes, what is happening outside, and in this scenario you always be prepared to stop.
Okay, yeah.
When the light is faulty, you don't jump like we do somewhere else. Not in the UK. Yes.
Yes. Yeah.
And if you are here, you need to follow. When the light is faulty, then you always prepare to slow down, stop it,